because this is a generated file, I need to go into the generation templates for it. It's entity data. So we're going to do our metaprogramming stuff here. Because we're writing code here that's actually writing other code for us. So we're going to take a group here and a type. And where is our, yeah, it's right here. So we're going to do like so. What we're doing here is we're writing, this is a template for an actual file, which will be generated code. This is get animations for set and type. Should be the name of it, I believe. Basically what we're going to do is, since we're not going to use like a dictionary, we can just use a switch statement on the set, and then we're just calling get animations for set on it, just like so. We have our group. Is that true? Should be our animation group type. No, yeah, it should be not a group, but it should be the animation type. So we have, yeah. Where's animation set? Yeah, there's the set. So we need type, and then we need the set. And this should be on the entity animation data, so this is wrong right here, so we're just going to get rid of that. Yeah, it's this one. We need to, yeah, oops. Type, and then we just call it for set. I'm going to regenerate all of our code. Excuse me. And we should see our new function pop up with all of our new shiny stuff. So there it is. And yeah, there we go. Like get animations for set is totally getting called. So we have what we need. Supposedly. Let's compile it and make sure it didn't screw it up. And the reason we're doing some of these things with code generation is because a lot of these values show up in the editor and things that we edit, and it's a real pain in the ass if we have to type all this stuff out by hand. Like you saw, I just wrote a very small amount of code, and what it actually went and generated for me was these big switch statements here, which reference actual variables instead of like lookups in a map or something else. So what that's doing for us is it's allowing us to have faster code without compromising the maintainability of the code. Because if you're able to do, there's usually a trade-off when you're coding between having stuff that's easy to work with and having stuff that is very explicit. So like if you always wanted to do some specific operation on something very specifically, it can be a real pain in the ass to type everything out in a very specific way. So you end up making like a generic function to do something. And then it becomes very difficult to debug because it's like, well, all the effects in your game, like for buffs, go through the same function. And so if you're like trying to debug it, you have to like fix that one function, as opposed to if there's like just like a strength buff function. Alright, so we want this new method that we just wrote, which is get animations for set and type. And we pass it anims, then type, and set. That'll grab our actual animations. So if anims.num equals 0, well, we're just going to return false. Like, if there are no animations of that type, then screw it. Otherwise, we're going to return can play animation anims sub 0. And that's going to call our can play anim with an anim wrapper. I don't think we ever have an animation ID on any of these things, so maybe we just need to remove this can play animation by animation ID. It's just not going to be useful, so let's just not waste our time making it. So let's see, can play animation. So let's see exactly what we got in our animation wrapper. It's an entity data, our animation wrapper. It's got a flipbook pointer and all of that sort of things on it. So let's see what this paper flipbook has on it. I think it's got sprites. Yeah, so paper flipbook has keyframes, a set of keyframes for the flipbook. Each one has a duration and a sprite to display. So this is a protected thing too. So how do we get them? Get collision, returns the collision source of the flipbook. Get collision source, collision mode type. Yeah, so it looks like what we want is we want to get the collision objects. So if our flipbook is null, again we just return false, we can't play that thing. So the flipbook has these things. I don't think these collision objects are exactly what we want though. Like what we actually want is we want the sprites at each one of the frames. Like we want this get sprite at frame. So it's basically this like for int, frame equals 0. We want, int32 frames is going to be book get num frames. Num keyframes? And then we want get keyframe checked. Yeah, so we want get keyframe checked. That's a paper flipbook keyframe. So we're going to call book get keyframe checked. That's totally right. What are you complaining about? Qualifiers dropping bindings. Bindings. Reference type. Oh, it's const. Const. So what is this guy? This keyframe has got a sprite on it. So basically we've got a new paper sprite. Sprite equals key dot sprite. So if sprite equals null pointer, we're just gonna continue. What's the sprite got on it? So we should have like these collision objects. And the collision objects are protected. Do we have a get collision objects? Yeah, so we have a get collision objects right here. So get collision objects on the sprite. And that should be this objects equals this. And it is a const array. Alright, so we've got this paper sprite collision object, which we've got the object content hash, so we're actually going to want to go through each one of these objects. So this is going to be collision object and objects. And again, this will have to be a const, I believe. The collision object content hash. Then we have the type, and we have the object code. So which one are we actually calling that gives us the channel for this thing, which is in paper? Paper it's in paper flipbook component .cpp get code. It's collision channel map on the ident code. So it's the inner object identifier code. So we need to call physics utils and figure out what that code is going to be, and it has to be phys. Otherwise we don't care about it. So there's a group and a code, so we do need our group and our code. Physics object type code, yeah, that's what we want. So object type is going to get object type code. I'll pass in this object ident code. And basically we're going to say if the object type does not equal a physics object. Then we're going to have to go get it. This is going to be collision object object ident code. It's not an animation constant, it's like an entity constant. Yeah, so it's going to be object ident code e.g. phys is what we need. So if it's not the right type, we're just going to continue in our loop. Otherwise, what we need is the content hash of this object. Basically, we need a set of pointers to collision objects. So we're going to have a t set of paper sprite object pointers. I mean, should it be a set or should it be a t map of integers to, yeah, so it'll be like int32. So it'll be object map. So basically, if object map dot contains object content hash, then we continue. Otherwise, object map dot add, and it's going to be the object content hash, and we're going to add the address of collision object. And these are going to be const pointers because we can. So once we have gone through this, basically we've gone through every sprite on every keyframe, and we've grabbed every object out of it. Which is unique, and that basically tells us all the objects that we have to test against to figure out if we need to collide. So how are we supposed to iterate over these T-maps? Well, I think you can just do like a for auto iter in object map, and I think iter dot, yeah, it's got iter dot key and iter dot value. So When all else fails, just use auto on something. If you're not exactly sure what the frickin' type is. I don't use auto unless I really have to. So this is going to be object equals iter.value. So basically what we want to do is we want to do an overlap check with this shape is what we're doing. So how exactly do we want to do that? I think we've got overlap shape. And we need to get like our current rotation is what it looks like. I think we can do it this way. So we're going to need our position. Our vector pos is going to be get position. And this is, you know, an expensive check to be like, can you play this animation? To go over every single one of the frames in the animations, their physics stuff, and collide it with the environment. But we're probably not going to be playing too many of these. And really the only character that's going to be doing all this complex, like, can you play this animation, is going to be Bitey. You know, this is really just to keep our player moving around properly. The rest of our characters, they can break physics a lot more easily than the main player can. If the main player breaks our physics, then we're in some serious shit. So what is our F collision shape? Sphere, capsule, box, line. That's not what we want. Well, we're just gonna have to figure it out. So we do need our F quad, our rotation. So we got a rotation. The collision channel, we're going to need to call get collision channel for group or something like that. Get collision channel for physics code. Yeah, it's get collision channel for physics type. Yeah, so that's what we're going to need. And do we have a group? Should be on like Dashkin entity actor. Is that where it is? Get entity group, yeah. So that's our channel. We have a T-array of overlap results, so let's get those. And we probably can like go through all this stuff as we. That might be actually a better idea. So grab everything here at the beginning, and instead of like building a map of stuff and iterating over it, we can just make a T set here of N32s that we've already checked. Just gonna call it check set, and so it's gonna be like if check set contains the hash, then continue, otherwise check set.add object content hash. And we'll return true by default, and basically we just just while we're going through here, we'll return false if our overlap doesn't work. So we need hits right now. We call it overlaps. Be more specific. And we need the shape. So we're gonna need like if this, then we return false, and just like info log. We collided on frame %d. So we'll go through, in the first frame it collides, it'll early out. So if this check is only the most expensive if we don't hit anything, which makes sense. And really there's only going to be like 1 or 2 boxes on this entire thing. So it's going to do like 1 overlap shape check, to be honest. And then it's just going to iterate over the rest of the frames. And it's just going to be like, oh, I've already checked that, so it'll just be done. Won't do anything. So we don't exactly want to overlap the shape. We would really like to overlap the body or whatever. So let's see if there's something more specific in our world. And we can do F collision shape, which I think is kind of what we want. It's like overlap blocking test. So it's like overlap multi by object type with the F collision shape. Yeah, so it's right here. It's F collision shape. Shape is going to be equal to well, this can only be called on an actual physics component. And what have we got on our collision object here? We've got our object type and our U-body setup. And our object type is either a circle or a rect. So we're basically going to create a box or a circle based on this thing, and that's what our shape is going to be. Because we don't have an actual like collision shape, we're going to have to make one. So I think we'll have a F collision shape pointer. It's going to be shape, and we'll pass that in there, star shape. And basically we're going to say like if our collision object dot what object type equals circle will make something. Else. Yeah, maybe we should just do shape and then we'll just fill it out. Is it make sphere? Is there a position? No, there is not a position. Not on these shapes. You have to actually set the position of the shape, it looks like. So it's going to be like shape equals F collision shape make sphere, and the sphere is going to have a radius, and that radius is going to be, looks like it's just going to be the size. That's what we got. So collision object dot size dot y. All right, and we're going to have our F vector pos offset. And our position offset is going to equal the collision object dot position. It's a vector 2D. Huh. All right. Well, pos offset dot x. Well, it's gonna be y and z, aren't it? Might be. We'll have to double check it. So we're going to make a box, and it's got half extents. So it's going to be the size divided by 2. The vector half, so half dot x or half dot y equals collision object dot size dot y times 0.5. So it's going to be the position offset. We're actually going to add the offset, but we need to transform the offset by the rotation. Do we? Yeah, we're going to need to transform this thing, I think. We just need to transform the position. So we need to, can we do that? Rotation dot transform vector, like rotate vector, and we just rotate the pos offset, and that actually returns a vector, so pos offset equals that. So we just do position plus position offset, shape, rotation, channel overlaps actor. So let's go take a look at where we actually set the size of this thing. I think it's Dashkin texture tool. .cpp, is that right? Yeah, so it's X and Y, the position is such. Let's take a look at flip a component. Our body setups. Do we have a body setup on here? Yeah, we do. So we're actually inside the Dashkin texture tool creating the body setups for these things. Now the other question is, can a U-body setup, can we get the collision shape? Doesn't look like we can get a collision shape from it. There's like just get volume and just like get data about it, get volume, rescale. Is there anything higher up like a U object, collision, something, shape or anything? There's just like add shapes and add collisions from other things. And I don't see anything in there. So, what are we seeing here? Sprite geometry collection. Well, would it be a decent idea to retrieve the actual... Where are you to find? Let's see if I can actually find you real quick. With editor only data. Okay, so no, that's not going to be available except for inside of the editor, so that's not a good idea to go grab that at all. Because it won't compile. It'll just break. And our position is... Okay, that's set properly. The size is the actual width and height and all that stuff. I think it works. So, is this going to be inside of paper sprite.cpp? Let's add rectangle shape. Yeah, it's actually going to compute half the size on there. F sprite geometry shape, new shape. Box size, box position. Well, I think that'll work. And my question here is if this is going to our X or our Y for our actual stuff here. So it looks like yeah, we might just want to be setting our X and Y halves here. And for our Z, did we do anything? So this is gonna crunch these things into like a body setup, I believe. Process geometry, add box to body setup. So it's going to do, it's going to use box size in the 3 dimension is going to be X. Collision thickness. What is collision thickness? It's just 10. Okay, cool. We'll just set that to 10. So it's just like half dot z is frickin' 10. All right, no problem. We'll just throw 10 in there, and let's make sure to put that in our globals. Because if there's anything we're hacking in there, let's make sure to just throw a big hack around it. Make sure we realize exactly what sort of idiocy we're doing. So, static const float half g sprite thickness. And that's gonna be over here. Const float sprite thickness is 10. Okay, so what this should do is we should make a shape. We have the position and the position offset properly here. X and Y. I believe these also should be X and Y, and the rotation should actually do the correct stuff with it. So pos offset dot z equals 0, but we could just as soon do f vector 0 vector right here. We don't have to worry about that. So if it's a circle, make a sphere out of it. Otherwise, make a box and just do it. So we could probably make this more efficient by having these collision shapes already created, just by like throw an F collision shape on the actual sprites when we create them in the editor. But I mean, that would just make sense. Let's see how this actually compiles though. This might be basically what we need. It's a little bit messy. We're iterating over every frame and making our collision objects out of it that we need to. There's not going to be too many collision objects though. Then we're going to check those against the world to make sure we can actually start playing that animation. We got enough room to do it. Then we actually got to test this thing. Alright, well. Alright, so we wrote a whole bunch of code, and great, let's boot up the game, and let's create a test case for it. So what we want to do is we want to see if we can play a specific animation. So we need to set up an animation that's got something on it that's that's going to fail this test. Let's see if anything is already set up for us. Well, all of our collision for all of our objects is pretty... There's nothing here that's gonna trip our stuff, so we're gonna need to do something. Like, let's change maybe air rising, and let's do something about that. So let's go to D air 2. I think that's the one that we got going on here. Is that what it looks like? Yeah, that's what it looks like. What we're gonna do is we're gonna go to our PhysRect, and let's make it bigger. So like maybe a 1.0. Let's make it a 2.0. So he's got like a big box there. And we're gonna also double check that everything works just by having 2 different ones of them. And let's go ahead and export this thing. So how we got it set up is we're building out our characters in Toon Boom Harmony, which is very similar to Flash, if anybody's familiar with that, except it's better than Flash in every way for artists. And then we have all these little rigging layers and physics objects that we can just kind of slap on there. And we export all the sprites, and it renders out all the frames and does all the stuff like figuring out where the origins are, writing out all the data, deduplicates all the frames, and makes sprite sheets for us. And then once we have all those, we can import them into Unreal, and it'll just nicely go into our already set up sprite sheets and flipbooks. So you can see just even this guy has got 120 sprites on him. So awesome. We're going to disconnect from source control here real quick. And import this stuff. And save everything. Let's take a look at what FatSack looks like now. So as you can see, his air rising has most of the frames are with that much larger hitbox now. So good. That's what we wanted to do. Let's make sure to save everything. Let's connect back to source control. And exit this editor. And then go and actually reconcile all the changes. If you do that without disconnecting from source control, Unreal doesn't do source control stuff very intelligently, especially with Perforce. It like runs through every single file and runs like a checkout command on every frickin' file. So like if you've got like this is some ridiculous number of files, like if you've got like 500 files and each one of those takes 100 milliseconds, then you'd be looking at 50 seconds of just sitting there waiting for it to like check out a single file. And it's actually slower than that, and it does it multiple times. So you're actually looking at more like 5 times that. So you're looking at 250 seconds. You're looking at like 5 minutes. You're just sitting there when if it had just run one goddamn command on Perforce, it'd already have been finished. So what I'm going to do is I'm going to hook up, we've got our virtual controller here. I'm just going to have it so when I press the X key, I'm going to have it check the animation for us. So I'm just going to do if virtual motion controller is key triggered, yay action. Let's just do B action. Then we're going to call movement we'll say can play animation, and we're going to give it a type. And the type of that animation should be this air rising. I think those are entity constants. We need animation constants. Yeah, it's AT air rising. That's what we need. Bool can play equals this. So if can play, else. We can play our air rising animation. Otherwise, info log, we cannot play our air rising animation. And we'll check out all of our files again. Cool. So we should be able to check our code now and make sure it actually does what the hell we want it to. So we should be able to run over and get it to tell us like we collided on frame 1 or on frame 2. And we should be able to run, I think, over to one of the little things and see exactly what it's doing. So, nothing too insane. We should just now have our per frame animation collision check for our animations, and we will be able to see if we can do things like standing up. So if we're crawling under a log, we can just be like, hey, can I stand? And it'll be like, no, dude, you can't frickin' stand up. Because frame 5 of the stand animation collides with the log above you. Which is exactly what we want. Actually just gonna exit this so it saves that state in the editor with the log window open. And reboot it. So not the most crazy interesting portion of 2D physics stuff, since we're just verifying all of our math and doing things like that. But a very necessary part of it. So when we hit B and it says, yeah, we can play our air rising animation. If we go over here, it says we can play it, and that's we cannot play it. We can play it. We can play it. We can play it. We cannot. When I hold the left key, it says we cannot. Interesting. We cannot, we cannot, we cannot, we cannot, we can, can. Alright, let's put on trace tag dash. Maybe I should make a new trace tag. We cannot play our air rising. We can play. Cannot. Yeah, okay, so something's... We're gonna zoom in the camera a bit. And let's also, let's see, this overlap shape. I'd like to put in another little debugging thing into it so I can turn just that on. This is physics utils, so overlap shape. Did I not add a trace tag to this thing? Is it query collision params that have got the trace tag on them? Yeah, there's no trace tag on here. Alright, so we're gonna grab another trace tag on this one. So the trace tag will let us see our tests with a specific. So we're gonna call this the shape overlap tag. I'm gonna call it overlap. How about that? So let's see, which one are we calling it? It's overlap shape. So we just need to do params dot trace tag equals this. These are just some basic tests that I threw in there. Are any of these get bounding box for components? Rotate by velocity, we don't need those. Overlap shape, overlap capsule. Overlap box, sphere, shape, here's a shape. Params, trace tag, overlap components. These are all sweeps. Okay, I think we've got one there. So I should be able to do trace tag overlap, and I should start to see what's going on here. And that'll let us know. I think basically one of my rotations or my positions or something else is screwed up. This will let us see the test, and I can immediately just see that I'm probably just screwed up on one of our axes. So, nothing too insane. Yes, F name. So let's fix that.